fine tuning. Center detented RIT control. It's dirty, needs cleaning. I haven't turned this on in 10 years. Turn it off frequency a little bit. I hear nothing. 10 watt scale. Forward power. Let's see how many watts. Almost 6. It's set a little bit too high. I better crank it back a little. I designed it for 5 watts output. If I run it more than that, this MOSFET gets a little hot on the RF amp I built for it. Right? I think it's an IRFZ 510. I'm not sure now. 520. Right on. Anyway, this thing sounds phenomenal. It is so much quieter than the Yaesu. Believe it or not, it is. This rig here's got some dynamic range now. It didn't originally have AGC, but I built AGC in because it about scared the shit out of me, man. With this rig, the dynamic range is so high. With no dynamic range, with no AGC, you go tuning around, you're gonna blast your eardrums, man. You blast your speaker. I found the best way to deal with it is to use it with AGC on as you're tuning around. When you settle on a station you like, you can turn the AGC off if you like. Right? I love this radio. I want to see what I can do. Maybe I'll crank it down to 1 watt. It was originally designed as a 2 watt output board. It uses a small Wonder Labs SW40 kit, which I highly modified with a new local oscillator. One moment. I redesigned the local oscillator, and I redesigned it with a 16 megahertz IF, and I redesigned the post TX mixer bandpass filter. That's what that is. This radio uses a transmit mixer. It mixes an oscillator with your local oscillator signal, just like it does in receive mode with your product detector. Yeah, it does the same thing for your into transmit chain. It has to mix the 5 megahertz local oscillator up to 10 megahertz. Come on, man. How old? Okay, here's your Morse code test. How old did he say he was? I hope you're well. I'll talk to you later. Bye, guys. By the way, this will go pretty loud while driving an 8-ohm speaker. That's loud here. And I'm using my 8-ohm shack speaker. What I did was I built this with a LM386-4 audio amp chip. The LM386 has 4 variants. The -4 version is a 1 watt output. Yeah, right on. This guy here is pounding loud. That's why I need AGC. See? 73. Bye, guys. Hear that? If I want to sit parked on the QRP watering hole frequency and hear some band noise so I can listen for the weak ones, Oh, I'll tell you what. You better have the AGC turned on. Why I say that muddily. You better have the AGC turned on if you want to sit there with it set like that. Why, if you don't, the dynamic range is so high on that radio. If you don't, man, you get a loud signal. Call CQ. It'll rock you right out of your chair. That's November 2, Quebec, Lima, Victor, and he's in New York. He's a POTA op in New York. That's the first contact I've made with this rig in at least 10 years. I moved back to Michigan 10 years ago, and I haven't used it since I've been back here. So, yeah, still works a treat. Hey guys, I wanted to show you around the interior of my little transceiver, my Superhet 30 meter Homebrew radio. I wanted to show you what's in the box, okay? One moment. I swear to God, I will never learn to clear my throat before hitting record. As I mentioned in a previous segment, I believe, this board is from Small Wonder Labs. It is an SW40 QRP transceiver board kit that was sold. Utterly fantastic price. It's shocking what people are selling this stuff for. You could never buy all the parts and build your own for that. Anyway, what's inside here? I'll talk about this board I'll talk about it more in a moment. I'll zoom you in on a couple different areas, but I wanted to show you what I've added to the basic transceiver board. Okay, one thing I added was RIT, R-I-T. Some people used to call it receiver incremental tuning, but that's not at all what it is. It's receiver independent tuning. I added RIT. with a center detent control pot. I added a 5-watt RF power amplifier. That board is capable of outputting between 1.5 and 2 watts. I wanted more. I built this RF power amplifier. It's capable of about 8 watts, but it runs just too dang hot at that power level. So I run it at 5 watts and it runs just nice. Gets warm, not real hot. Okay, so RIT RF power amplifier. These two boards, they're stacked. There's 2 of them. The one on the bottom is an audio power amplifier using the LM386-4 chip, which I talked about previously. Okay, that's on the bottom. This board here on the top that you're looking at, that is that's my AGC board. It offers 2 different hang times, selectable by this jumper. You move the jumper. I wasn't sure which AGC timing I wanted, so I gave myself that option, and I chose the one that I preferred and left it. It's not like there's a 2 AGC option on the front panel. There's not a switch to select them. Could be, but it's just not necessary. So that's what I've added to that Small Wonder Labs board. Let me pause you and zoom you in on that board. One moment. Oh, I just whacked my desk. You know what I'd like to do? I'd like to talk about Superhet architecture. I'd like to walk you through the schematic for this radio and teach you guys how a Superhet receiver works and a Superhet transmitter, a Superhet transceiver. I'd love to walk you through the schematic of it. I think I could do a pretty good job. I think I could explain it in terms that the non-radio technician would understand, I believe. Uh-oh, hang on. Oh, shit. The baby boy saw a squirrel, I think. In this section up here is the local oscillator, what you might call a VFO. I did a lot of work with it trying to mitigate drift. This toroidal core is a T68-7. The 7 mix is much more stable temperature-wise, and especially so if you boil that toroid core for 15 minutes to anneal it, which I did. I wanted to do another video just on that, on mitigating VFO drift in a QRP transceiver kit. And I will. I don't know if anyone would watch it, though. This is a TX oscillator. This is the post-TX. His barking now, I can't think. I can't even think. Hang on. Oh, my God, how can I compete with that? Oh, freaking rattle brain now. It's a bandpass filter. It's a post-TX mixer bandpass filter. That's what that chip is. It's an SA612. Oh, come on, really? Yeah, I guess I've said enough anyway. If anyone wants to see a talk about how a Superhet receiver / transceiver works, let me know. I'll talk to you later. Sorry I got so discouraged because of Hunter's barking. I really wanted to show you around a few things, what I've done to this. So I changed the band of operation, like I said, from 40 meters. For a while I had it running on 20 meters, but this is its final revision. So I've changed its band of operation to 30 meters. I changed the IF frequency. These are the IF crystals, these 3. I changed the IF frequency from 9 megahertz to 16 megahertz. And if anybody wants me to walk you through a Superhet design and talk about how it works, I can talk about IF frequency choice and talk about why I chose 16 megahertz rather than 9 for this new band. I added an adjustable BFO trimmer cap. It was fixed in the original board. I made the BFO adjustable so I could set it for optimum opposite sideband rejection, coinciding with the sound I prefer. You know, when you adjust that and you listen to the audio, you'll hear just like on your Kenwood, right? Well, I made BFO adjustable. And I added an adjustable transmit heterodyne oscillator trimmer. It was fixed as well. So therefore, the frequency, the offset, the receive transmit offset, which normally you'd have about 700 hertz, well, it wasn't adjustable. Now it is. Right. And right now I have it set for an offset of 700 hertz. And that's what you do. First you set your BFO, your IF passband, and then you set your transmit offset. I designed a new, so your transmit chain has your local oscillator connected to a mixer along with a heterodyne oscillator. And the product of the two is your transmit frequency. This is a bandpass filter that follows the mixer. I designed my own for better performance and for easier adjustability with those two trimmer caps. The original bandpass filter was not adjustable. This one is. I worked with the local oscillator section like I think I've already mentioned in this video. I keep recording segments and forgetting what I've talked about. But I chose a toroid type T68-7. The 7 mix is better for thermal stability. And like I said, I annealed it by boiling it 15 minutes. One could coat this with Q-dope once it's done, but I chose not to. This trimmer is that is a RF gain control. It used to be, I used to have this as the RF gain control, but I found, I didn't really, I'd rather have this be fine tuning. So now it's a fine tuning control. Let's see, what else did I do? So I stabilized the local oscillator as best I could. I was going to do a video about QRP kit stabilization. I think for Kurt. I'm not sure, but I never did it. Let's see, what else? And like I already said, I added a RF power amplifier and a AGC, and underneath it an audio power amp and a RIT circuit. And that's what I did. And so, right, those are the changes I made. I hope you're well. I'll talk to you later. Bye, guys.